In this question, a constant force F pulls a 50 kilograms block at a constant speed over a rough horizontal surface AB, as shown in the diagram. The coefficient of kinetic friction between the block and the surface is 0.4. And the first part of this question says, draw a labeled free body diagram showing all the forces acting on the block. And so here is how we can answer 3.1. We know that in a free body diagram, the object is represented with a dot. So this dot here would be a representation of this 50 kilograms block. And here we have an applied force, which is at an angle of 20 degrees to the horizontal. So if here this is a line that is parallel to our surface, we know that there is an applied force and we can call it FA if we like. So A for applied, and it is at an angle of 20 degrees. Okay, and in addition, this object is going to experience a gravitational pull right towards the ground, and we obviously call that the gravitational force, or sometimes the weight of the object. Okay, and this one is always directly downwards towards the center of the earth, so it's always directly downwards. And now in addition, since this object is in contact with a surface, that surface is going to exert a normal force on the object, and the direction of the normal force is always upwards, perpendicular to the surface. So since our surface here is a horizontal surface, the normal force is going to be upwards in the direction opposite the gravitational force. So this will be a normal force. And in addition, in the statement, we were told that this is a rough horizontal surface, and they even gave us the coefficient of the kinetic friction, which means that this object here will experience some friction. And now the direction of the friction is always opposite the direction of the applied force, or opposite the motion of the object. And so this will be our frictional force. And therefore, this would be our free body diagram showing all the forces acting on the 50 kilograms block. And you will actually notice that although this is a rough sketch, so these forces here are not necessarily drawn into scale, but I have made the normal force here quite significantly smaller than the FG. And I have done that on purpose. I will tell you why I have done that as we are going through the question, but right now just keep that in mind. So we can now move on to 3.2. And here they are simply asking us to state Newton's first law of motion in words. And I trust that you can manage to do this, right? If you are unsure, you can just check it from your notes or textbook. But of course, the most important thing is to make sure that you understand exactly what this law is saying or what it is about. So for now, we can move on to the more interesting question, which is 3.3. And now here we are asked to calculate the magnitude of the force F, which is what we have called our applied force. Okay, so we want to find the magnitude of this applied force. And so here, the key thing that they gave us in the statement is that this block is moving at a constant speed. And you need to know what is meant by this. So what this is telling us is that the net force acting on the block is equal to 0. Okay, because if something is moving at a constant speed, it means that there is no resultant force, or the resultant force is 0. Or in other words, it means that the acceleration of that object is equal to 0. And from Newton's second law, we know that acceleration is directly proportional to the net force. So if the acceleration is 0, it means that the net force is 0. And so for 3.3, what we know is that the net force that is acting on the block is equal to 0. And now this net force here can be resolved into the vertical and the horizontal component. And of course, we also commonly call the vertical component the y component and the horizontal component the x component. And so since our object is moving at a constant speed along this horizontal surface, and we know that it is not accelerating at all in the y direction or the vertical direction. So it means that the net force along the y direction is equal to 0. And in the y direction, we know that this net force is given by the gravitational force. So it's given by Fg plus Fn. And now you also need to note that the applied force has got a component in the y direction. And we can show this y component as follows. If we start from the origin and move directly parallel to the y-axis up until we reach the same level as the head of Fa, that will be the y component. So this vector here would be the representation of the y component of Fa. And likewise, we also have an x component of Fa, and we can show that x component by moving from the origin to the right directly parallel to the x-axis, as you can see, up until we are in line again with the head of the vector Fa. And so this would be the direction of this x component. So this would be the x component of Fa. Okay, and if we like, we can show this Fay on this side. So it is exactly the same as a vector that we can draw from the head of this x component to the head of Fa. So this is also Fa of y. It's exactly equal to this one. And likewise for Fa of x, we can also show it by a vector from the head of Fa of y up to the head of Fa. So this is also equal to Fa of x. So it's exactly the same as this Fa of x. Okay, and so the y component of Fa is also one of the vectors which contribute to the net force in the y direction. So we are also going to write it here. And all of these must be equal to 0. And now, if we choose upwards as our positive direction, we can show these forces as follows. First of all, Fg is downwards, therefore it will be negative. And we know that Fg is given by mg. So it's given by the product of the mass of the object in question multiplied by the gravitational acceleration. And then Fn is upwards, and so it will be positive, and we do not know what that will be equal to right now. And now for FA of y, we can actually write FAY in terms of FA here, using trigonometry, of course, because we know what the angle of FA is relative to the horizontal. And what we notice is that FA of y is opposite this angle, right? So this is an opposite side. Of course, an opposite of this right-angled triangle that has been formed by FAX, FAY, as well as FA, okay? And FA here, since it is opposite the 90 degrees angle, we call it a hypotenuse side, okay? And then from trigonometry, we know SOHCAHTOA. So if we want to write FA of y in terms of FA, what we say is that the trig ratio that can relate the opposite side to the hypotenuse side is sine. And sine of theta, or 20 degrees in this case, is the opposite over hypotenuse. And the opposite in this case is FAY, and the hypotenuse is FA. Okay, and so basically we can multiply by FA on both sides of this equation. And if we do that, this FA cancels with this FA. And so what we get is that FA of y is equal to FA multiplied by sine 20, or just FA sine of 20 degrees. So here, in place of FAY, we can write FA sine of 20 degrees. And we also need to recognize that FA is upwards. So its direction is upwards. So it will be positive. And then we can just write it as FA sine of 20 degrees equal to 0. Okay. And now we know the mass, and we also know the gravitational acceleration. So we can substitute in those numbers here. So the mass of our object is 50 kilograms. So for M, we write 50, and G is 9,8 on Earth. So we'll write 9,8. And then we'll keep what we do not know as it is, because we do not know, or we do not have any information at this point about the rest of these forces. Okay, and furthermore, we can also calculate 50 multiplied by 9,8. And so 50 multiplied by 9,8 is equal to 490. So here we'll have negative 490 plus Fn plus Fa sine of 20 degrees equal to 0. And now, unfortunately, we don't have any information about the normal force and Fa. So we are just going to leave them like this. We can just call this our equation 1. And now we know that there is also another component of the net force, but which is along the x direction. And this will also be equal to 0, because in the x direction, or the horizontal direction, our object is moving with a constant speed. So even in that direction, the net force must be equal to 0. And now in the x direction, the forces that are contributing to this net force is the x component of the applied force. So we have Fa of x, which is in the x direction, and we also have the frictional force, which is also along the x direction. And the sum of these two forces should be equal to 0 as well. And even here now, we need to choose a positive direction. And so let's take to the right as our positive direction, because we are now looking into the horizontal direction. So Fa of x here can also be presented or written in terms of Fa. So something similar to what we did for Fa of y. And so for Fa of x, we notice that here it is an adjacent side to this 20 degrees because it is next to the 20 degrees. So it's an adjacent side. So this means that we can write Fa of x as Fa multiplied by cosine of 20 degrees, because the trig ratio that can relate this adjacent side to the hypotenuse side is cosine. So adjacent and hypotenuse can be related with cosine. But now this is just a quick way of writing Fa of x in terms of Fa without starting by writing that cosine of 20 degrees is adjacent over hypotenuse. So adjacent is Fa of x divided by the hypotenuse, which is Fa. So this is, if you do not want to go through all that, this is a quick way of doing it. Because even here you can multiply both sides by Fa, and so this Fa is going to cancel with this Fa. Therefore, Fa of x can be written by Fa times cosine of 20, which is just Fa cosine of 20. And now this will be positive because, as we can see, Fa of x is to the right. So this will be positive. And then the frictional force will obviously be negative because it's to the left. So the sign of the frictional force will be negative. And we know that the friction, which will be kinetic friction in this case, since our block is moving, it is going to be the normal force multiplied by the coefficient of the kinetic friction. Okay, which is why they have given us the coefficient of the kinetic friction in the statement, and it is 0,4. So both of these should be equal to 0. And so we can substitute in this coefficient of the kinetic friction here. So we will have Fa cos of 20 degrees minus the normal force, so we can also write it as Fn multiplied by 0,4. So this should be equal to 0, and we can call this our equation 2. So as you can already see, in order to solve 3.3, we need to solve these two equations simultaneously, because we now have got two equations, equation 1 and equation 2. And in both of these equations, we have got two unknowns. We have Fn, which is an unknown, and we also have Fa, which is also an unknown. And so we can just solve them simultaneously. And so, of course, there is a variety of ways that one can use to solve a simultaneous equation. But so for this one, here is a method that I would advise. We want to find our applied force Fa. So what I am going to advise that we do is we rewrite this equation and make Fn the subject of the formula. So we can do that as follows. So we want to make Fn the subject of the formula, and so we need to move the 490 to the right hand side, so it will become positive. And then we are going to move this Fa sine of 20 to the right hand side as well, so it will be negative. So we'll have negative Fa sine of 20 degrees, and we can call this our equation 3. And now what we are going to do is we will substitute this equation 3 into equation 2. And if we do that, we will have Fa cosine of 20 degrees minus, and then where we have Fn, we are just going to write the expression of Fn, which is given by equation 3. And so to avoid mistakes with the signs, you need to write this inside a bracket. So in equation 3, we see that Fn is given by 490 minus Fa multiplied by sine of 20 degrees. And so all of that must also be multiplied by 0,4. Okay, and so this should be equal to 0. All right, and so now what we are going to do, in fact, we could have done this in one of the previous steps if we wanted to. We will find the value of cosine of 20 degrees. So let's whip out our calculator. And so what is cosine of 20? So this is 0,939, and we can just write it as 0,94. So it means that we will have 0,94 Fa. Okay, and now here, to avoid confusion, let's start by multiplying these terms by 0,4 while they are inside the brackets. So let's find 490 times 0,4. So this is 196. 196 is what we get if we multiply 0,4 and 490. And now we are going to multiply this 0,4 with this other term. So here we've got sine of 20. So we can calculate sine of 20 and multiply it by 0,4. And if we do that, we see that we get 0,1368. And if we round to 2 decimal places, this will be 0,14. So we'll have minus 0,14 Fa. So don't forget Fa. So let me remove this now. And all of this should be equal to 0. And now we can multiply both of these terms with this negative. So we have 0,94 Fa, and then a negative multiplied by a positive is a negative. So we'll have negative 196. And then a negative multiplied by a negative is a positive. So we'll have positive 0,14 Fa. And these are equal to 0. And now this is becoming simpler because we have got two terms. Both of these terms have FA, so these are like terms as we would call them in mathematics. Therefore, we can combine them together. So to combine them, we can say 0,94 plus 0,14. And if we add them up, we get 1,08. So we can combine them to 1,08 FA. And then we have a constant term here, negative 196, and we can just take it to the right hand side of the equation. And so its sign was negative, it will now become positive 196. And lastly, we can just divide both sides of the equation by 1,08, so that on the left hand side we are only left with FA, and then on the right hand side we will have 196 over 1,08. And using our calculator, 196 divided by 1,08 is equal to 181,48. So the applied force is 181,48 newtons. Okay, and so this would be the magnitude of the force Fa. So I have just noticed something. In the memo, the answer is 182,156 newtons. And the reason that the answer we have obtained here is not the same as in the memo is due to rounding. Here we calculated sine of 20 multiplied by 0,4. So here, if we had calculated the sine of 20 separately, sine of 20 we would have gotten 0,34. So I mean, it is quite reasonable to round this to 0,34. Okay, and then if we multiply this 0,34 by 0,4, we get 0,136. Okay, so this means that here we would have 0,136. Even here we would have 0,136. And then the implication of this would be that when we are adding up these two, we would have 0,94 plus 0,136. And so then our term here would have been 1,076. So instead of just 1,08. And if we now divide 196 by this answer, we get 182,156. But I mean, of course, the memo is just a guide, it's just a marking guide. Otherwise, in the instructions, you are told that you must round your final answers to 2 decimal places. So 182,16. And also, I am just clarifying this for those people go and check the memo and then say, what you told us here is wrong. It's not that what we have done is wrong. It's simply because of rounding. And I think it would be reasonable for the markers to accept a certain range of answers, because this is bound to happen because, people are not going to round their values the same way. Or alternatively, what is commonly advised is that you mustn't round your numbers up until you get to the final answer. Otherwise, the most important thing that you need to take from the tutorial video is the concept and the procedure that you need to follow in order to solve the problems. Sometimes the final answers may be incorrect because of small mistakes, but the most important thing that you need to take from this is the procedure, and then you can always compare the answers to the memos that are available. But also beware that the memos can sometimes have errors. And now for the last two questions, 3.4 and 3.5. In 3.4, we are asked to find the magnitude of the normal force. And so this is easy because we know that from the previous question, we had two equations, and we did manipulate one of the equations to give us the normal force. And here it is. And in this equation, we see that the normal force will be 490 minus the applied force sine of 20 degrees. So now that we know the magnitude of our applied force, so let us just go with this magnitude of 182,16. So we know that our force F is 182,16 newtons, and we want to find the normal force. And so for the normal force, we are going to use this expression. And so to answer 3.4, we are going to use equation 3 here from the previous question. And we see that the normal force here is 490 minus FA. So here we'll just write in the magnitude of FA, which is 182,16 sine of 20 degrees. And then, as usual, we just whip out our calculators, and 490 minus 182,16 sine of 20 degrees. And so this is 427,7. So we can write this as 427,7 newtons, so or 70 newtons. Okay, so this would be the magnitude of the normal force, which then brings us to 3.5, whereby we are being asked to find or to calculate the magnitude of the frictional force. So this one is easy because we know that the frictional force, which will be kinetic friction in this case, will be given by the normal force multiplied by the coefficient of the kinetic friction. So since our normal force is 427,70 and our coefficient of kinetic friction is 0,4, so the product of these two numbers is going to give us 171,08 newtons, because this is also a force. So these are the final answers for 3.4 and 3.5. And now the last part of this question says the same constant force F is now applied to the block over the same rough horizontal surfaces before, but in the direction that is shown in this diagram. And so this time around, this is how this force is being applied. And it's still at an angle of 20 degrees to the horizontal. And now the question here is, give a reason why the block will move slower than before. And to understand why it is the case, we need to draw a free body diagram of this scenario and also compare it to the free body diagram of the previous scenario. So here we can draw the free body diagram as follows. So this is a dot representing the 50 kilograms block. And here we've got this applied force. So if it is being applied at this direction, we can show it like this on our free body diagram. So the applied force this time around will be downwards like this, okay? And we still have the same gravitational force as before, Fg. So downwards as before, and our frictional force is still going to be pointing in the opposite direction to the applied force. And the surface is going to exert a normal force, Fn, to the block. And now we need to note that this time around we can resolve the components of these forces Fa as follows. So we have a horizontal component or Fa of x component here, and we also have a vertical component or Fa y component like this, and they are perpendicular to each other. And now you must also note that this angle from FAX to FA is going to be equal to 20 degrees as well, because if we were to extend this line here, FA, this angle is going to be opposite to this angle. So opposite angles like this are always equal. Okay, and now in the y direction we can show the forces as follows. Even here, the net force in the y should be equal to 0 because there's no movement in that direction. And this net force is going to be given by the normal force plus Fg plus the vertical component of the applied force. And now let us choose the upwards direction to be the positive direction. And this means that we are going to have a positive Fn. Fg is still going to be mg, and it will be negative because it is downwards. And now check this out. You will notice that Fa of y in this case is pointing downwards, which means that it is going to be negative. So we are going to have negative Fa of y, and this Fa of y is opposite our angle, so we can show it as Fa sine of theta equal to 0. And then we can make Fn the subject of the formula here. And if we do so, we will get that Fn will be given by mg plus Fa sine of theta. And so this is an expression which can give us the magnitude of this normal force. And of course, sine of theta is 20 degrees. And mg here is still 50 multiplied by 9,8. But now, if we compare all of this to the first scenario, this is what we are going to see. And so this is the free body diagram for the first scenario. And even here, as we had already discussed, F net in the y direction is equal to 0. And in this case, as we had already shown, this F net would be equal to the normal force Fn plus the gravitational force Fg, and then plus the y component of the applied force. Okay, and this must be equal to 0. And here we also took upwards as the positive direction, and so Fn is going to be positive because it is upwards. Fg is going to be negative, and we can represent it with mg. As we had already discussed, we can represent Fa of y by Fa sine of the angle theta, which is 20 degrees here as well, because Fa of y is an opposite to this angle. So opposite over hypotenuse is sine. And now in this case, Fa of y is upwards, so this will be positive. So equal to 0. And we can also make Fn the subject of the formula here. So if we take negative mg to the right hand side, we will have positive mg, and then we will have minus Fa sine of theta. And even here for our theta, we still have 20 degrees. Okay, so if we compare these two, you will notice that the normal force was given by mg, which is the gravitational force, minus the y component of the applied force. And in this case, the normal force is now given by Fg again, which is the gravitational force, but this time around plus the y component of the applied force. So as you can see here, the normal force is going to be greater in magnitude than the normal force that we had in the first scenario. So as you can see, since we are still talking about the same 50 kilograms block in both of these scenarios, everything is the same here. The mass is the same, and as it was discussed here, we are still applying the same constant force F, so this Fa is going to be equal to this one in magnitude. And then sine of 20 is also the same in both of them, but the only difference is that in this scenario, we are adding this y component of the applied force, whereas this time around we are subtracting it. So it means that this normal force here is going to be greater than this normal force. So the normal force of this scenario is bigger in magnitude compared to the normal force of the first scenario. And now I hope that this answers the question that I posed initially about the size of this normal force compared to Fg. That is why this normal force is smaller than this Fg. And if you come to this one, you'll notice that this normal force now is quite longer than this Fg. Okay, and this is because this normal force here needs to balance two forces. It needs to balance this Fg plus this y component of the applied force. Okay, because Fg and this component are both going in the same direction. So we need a significantly bigger normal force in order to balance both of these forces. But this time around, it's the gravitational force that needs to balance the normal force and the vertical component of this applied force. And so now to answer 3.6, the reason why the block is now going to move slower than before is simply because a larger normal force means a larger kinetic friction, because the kinetic friction is given by the normal force multiplied by the coefficient of kinetic friction. And this is still going to remain the same as before because it is still the same surface as explained in the question, and it is still the same block. But now the normal force is greater than before. So this means that the kinetic friction will also be larger than before. And so this block is now going to move slower than before because there is going to be more friction. And so this is how you can answer question 3 of this question paper. And basically, you can also apply the same procedures, concepts, and the tricks that we have used in this question paper to answer other similar questions as well, which is the most important thing that you should focus on taking from this tutorial video. So I hope you enjoyed it and you have learned something from it. And if you have watched up to this point of the video, please make sure that you subscribe to the channel so that you do not miss more videos like this in the future. And also like the video and feel free to leave me your feedback in the comment section below. Thank you.